Please sit down. We're gonna start. Okay. So I will start with the last part of lecture 4. Okay. So MATLAB has an order of calculation, okay? And it starts with arithmetic calculations, that is plus, minus, raised to the power, times. Those types of calculations always have preference. That's the number one thing MATLAB does. After that, you have relational operators, which is a relational operator is greater than, smaller than, greater or equal to. Those are relational operators. You're comparing yourself with someone else. Sounds like a relationship, yeah? Am I better than my neighbor? Am I more handsome than my neighbor? Yeah, so those are relational operators. And the last precedence that MATLAB does with calculations, the lowest order priority are logical operators. Okay, so let's go over this. Let's look at line 192. You see that I declare two variables on line 192. I declare a variable A and I declare a variable B. And on line 194, this is called a relational operator because I'm asking, is A larger than B? Yeah? That's the larger sign in between. Now we know that A is 2 and B is 4. So what's the answer of this statement? Is this true or not true? So if a statement is not true, then MATLAB would not tell you in written language that statement is not true. MATLAB will return a 0, yes. Now let's add another variable here, C, on line 200. And now what I have is I have a combination of relational operators and logical operators. So when you look at this statement and have no clue about the order of calculation, this can be really confusing because what does this say? This says A smaller than B and C smaller than B. Is it like A smaller than B and C and larger than B? So what does this mean? So this is where you need to know the order of the calculation. Now what we have here, we don't have arithmetic operators in here. The only thing we have is relational operators and logical operators. The AND, this is a logical operator. AND, OR, and NOT. Those are the logical operators. AND is a logical operator. So what do we know? In terms of precedence, that the relational operators are first computed over the logical operators. So perhaps it's easier if we rewrite this to a statement like this, where we first compute this A smaller than B. Now the answer of this was, when I pause, that means I'm asking you guys to give me the answer. Nice bike, by the way. It's a little small for me, but if this is the way that I'm being bribed, then a little larger and a giant. Okay? So the calculation here is A smaller than B. Now A was 2, B was 4. So we know that this is not true, so this returns a 0. Then C larger than B. Now C was 5, B was 4. So 5 is larger than 4, so this returns a 1. So now we have 0 and 1. And now it's confusing. What does this give as an answer? So we can just add the numbers in. A is 2, B is 4, Oh, C is 5. And now we calculate this statement here. The answer is 1. So, 0 smaller than A smaller than B. That is true, because 2 is smaller than 4, yeah. C is larger than B, that is true. So, if we calculate this jointly, what we have 1 and 1. And the answer will be 1. Okay? So when I write these statements, I always use these round brackets to make clear what is done in the calculation. Because if you leave these round brackets out, it can be very confusing. So always remember that the relational operators, that those are first calculated, and that at the final end, the logical operator comes in. So we first compute this, then we compute that, and then we have two numbers, in this case 1 and 1, and then we have a statement 1 and 1, and then MATLAB will return a 1. Now in this case an OR statement. Okay, so an AND statement will only return a 1 if both sides of the statements are true. Okay, so line 209, this will only return a 1, an AND operator, if both statements or multiple statements are all true. An OR statement, an OR logical operator, this line, will return a 1 if either one of those statements is true. So if only one of the statements is true in a logical OR, then it will return a 1. And in this case they're both true, so obviously then it will return a 1 as well. So again, here an example, a more complicated here. So look at this one. Now this is easy now. So the highest precedence, the power has a higher this is all arithmetic calculations, yeah? Line 224, when I calculate x, yeah? So what you should know is that raising something to a power has a higher precedence than dividing by. So what we have here is not 2 plus 3 to the power 2 over 4. What we have here is 2 plus 3 squared divided by 4. And why is it this way? Just a matter of convention, rules. Okay? When I write codes, I wouldn't write it this way. I would write it like this. So that anyone knows, even if you're not experienced, that the first thing we do is we raise 3 to the power 2, then divide that by 4 and add 2 to that. Okay? Now let's look at this statement again, 234. What the hell is going on here? Here we have an arithmetic operator going on, because 8 minus 2 is an arithmetic operator. Yeah? I have a relational operator because it says 3 larger than 8 minus 2. And I have a relational operator at the end, square root 15 larger than 4. So that larger are both relational operators. And then I have a logical operator, the or the vertical bar in the middle. So what have we learned now? What is the first thing that we compute? Yeah, so what's the first thing when you see this? So again, if I would write code, I would never write it this way. I would use round brackets to make clear what's done first, or to not confuse someone. But in principle you could write it like this. So the first thing that you do is just you go through the order of precedences, and that is we're first going to do the arithmetic calculations. And which are those? is 8 minus 2. That's the first thing that we're going to compute. And the square root of 15 is an arithmetic calculation, yeah? So what we have left then is y is 3 larger than 6, or square root of 15 is like 3.9 or so, larger than 4. So we have simplified the problem. The arithmetic calculations are gone because they have the highest precedence, okay? Now we know that after the arithmetic calculations are done, what we're left with are first the relational operators. So what we have is 3 larger than 6, or square root 15 larger than 4. Now, 3 larger than 6, is that true or not true? And so MATLAB will return 0. Okay, so now we have already solved the second step. We now have something that says y is 0 or square root 15 larger than 4. Is square root 15 larger than 4? So what's the answer there? 0. So what we have is y is 0 or 0. So what's the answer at the end? What is y? 0. What if it would have... Yeah, okay, good. We'll leave it with this. Now, that's simply how it works. And I add a lot of text to this, okay? Just for convenience. Now, let's go to lecture 5, where we start with if-else statements, because that is where I end lecture 4, okay? So, what are we supposed to learn today? We're supposed to learn today if-else statements. How strange suddenly. How to work with switch statements. How to use for loops, the break and return command, how to work with vector operations and loops, pre-allocate memory, how to work with logical operators, and use of the find function. Now, to be honest, these things between line 5 and 13 or 6 and 13, this is, you can give an entire MATLAB course on. And we exactly have left 35 minutes. Okay? I know you guys all have a GPA above 4 when you entered UCI, yeah? But this is a little, some lower, but this is a little, this is a lot, okay? So we'll try to do it slowly, okay? So we'll start with if-else statements, okay? And again, please go through my scripts. I sent them ahead of time, as you've noticed. Just work on it at home. Because then, first of all, you know the answer. So when I ask a question, you already know the answer. Yeah, and then I actually think you're a smart student. And then I write that down when I come home, yeah? Extra credit at the end, yeah? Line 27, we start with an if-else statement. On line 27, I specify a scalar named A, and I tell MATLAB A is 4. Now, fantastic. MATLAB now knows there's a variable called A, and that's equal to 4. And now on line 29, I start an if-else statement. And that's always if, else, and. Okay? So if you look at this entire statement, this is the easiest if-else then statement, if-else and statement that there is. I ask on line 29, using a relational operator, whether A is smaller than 0. Is A smaller than 0? So do you think that MATLAB will execute line 30? No. Else, because that statement on line 29 is not true. On 27 I said A is 4, and on line 29 I asked the question, is my mom, her IQ, smaller than 4? Now, in reality the answer is yes. But in this case, the answer is no. Because the IQ was 4. Okay. So, if A is smaller than 0, what do? I display to the screen, hello. It's a song of Neil Diamond. Bless you. That's not a song of him. Then line 32, if my first if statement is not true, then I execute what is under else. So in this case, what this will do is that it will display to the screen by, because the first statement on line 29, if a smaller than 0 is not true, returns a 0. MATLAB then knows execute the else statement. And that's at this display by. So I can execute this, I can copy this to the screen, and then I can copy this to the screen. And what you see, MATLAB says by. So I know now that A is larger than 0, larger or equal to 0. Okay, now another example here with two scalars. X is -1 and y is -2. And then an if, else, then statement. And the first thing I ask on line 38, is x smaller than y? What's the answer of that statement? So that's not true, yeah? Because -2 is smaller than -1. So x is -1, y is -2, so x is larger than y. So line 38 is not true. So that means I will not execute what's on line 39. I will automatically execute what's in the else block. That's line 41, and that is that my constant c is y minus x squared. So I can, of course, do it like this, and then copy this, and then I'll have c is 1. And why is c is 1? Because I have -1 or -2 minus -1. That becomes -1, and I square that, so c becomes 1. And these if, else, and statements are used a lot in programming, okay? They're used all the time. Like the FBI, for instance, you're a terrorist, yeah? And you like to fly. You're at Amsterdam airport and you installed a bomb in your shoes. Yeah? There's people that do that. Okay, they take a Delta flight to Detroit, and the FBI, they have a very nice system in Amsterdam, basically in Amsterdam, because I've done that many times, not the bomb part, but the flying part. And then they have people standing there, security people, and they have a desk like this, and they ask you for your passport, yeah? And then they ask you a question like, so do you transport like any liquid materials, anything else, or a bomb? They just ask you that question, yeah? And then if you're a terrorist, you're thinking, nah, what should I answer on this question, yeah? So the way they do that is not really like in my way, it's rather strange. So I start asking them questions like, so you're asking me questions, so how long have you done this job? Well, I changed the conversation, yeah? So one time I asked this lady who was talking to me, he said like, I asked her like, how useful is this really? Like, yeah, a terrorist, yeah, that has a bomb, yeah? Are they really gonna say, yeah, I have a really big bomb in my bag, in my check-in luggage number 239, you better check it out, yeah? And she said, but Jasper, and he said, Herr Vrugt, that's very German. So he said, like, how many times have you seen an airplane explode at takeoff from Amsterdam airport? So that justified, basically, their approach. Basically, based on that, their approach was working. And then I said, yeah, not very often, but to be honest, if I go to Frankfurt or I go to London, I've not really seen that either. So any airport is rather strange there, like from takeoff you see an airplane suddenly explode. I mean, there's very few airports in the world. Maybe, you know, if you went to Iraq or so, that could happen. It actually happened to a FedEx plane that took off back that airport. It was a missile, was a local some terrorists, some local terrorists, they had a rocket launcher and they hit an Airbus 330 FedEx, okay? It was a Belgian pilot, okay? So it's tricky, and he had two co-pilots, okay? One from Scotland and one from England, I believe. So they were at like 8,000 feet, and those rocket launchers make it up to 10,000 feet. So those planes know from takeoff, there was a war zone at that time, that I need to make it to 10,000 feet as soon as possible, because they know that local terrorists have those rocket launchers, and there's nothing more they like than shooting down airplanes, because that has big impact in the West, yeah? Now, so they did. So they fired a missile that hit the wing, okay? Now, that's, you know, imagine you're sitting as a pilot, you're smoking a cigarette, your cocaine next to you, drinking a beer, yeah? Having a good time, and suddenly you look over your shoulder, you're like, oh, my wing is on fire. No big deal, you go to the manual, what should we do when we're hit by a rocket? And they didn't know what was going on, yeah? So anyway, the whole plane got destabilized, and they managed to land safely, believe it or not, on Baghdad airport. You can find this on YouTube. All these movies, like I like to watch these videos like air disasters, yeah, where you step in an airplane like an Airbus 380, and suddenly, you know, there's not enough fuel or so, and you're on the ocean, yeah. Like, what are you going to do? That happens nowadays, believe it or not, and they have those if-else statements in airplanes as well. That says if there's not enough fuel, then give an error warning in the cockpit, yeah? So watch those movies. They have a lot of if-else end statements. But anyway, this was the first pilot ever that was able to land a plane under those circumstances, okay? Basically with one wing, okay? The whole hydraulic system was gone. So planes land based on a hydraulic system. Like when you want to switch direction, you use your hydraulic, you use your flaps, yeah? The flaps go up a little bit this, and then you make a turn. There were no flaps anymore. There was no hydraulic system anymore. So what he did, he used differential power on the engines to move around. But the plane kept going up and down, and finally they landed, and they landed safely. And ever since, NASA has had renewed interest in landing planes without hydraulic power, but because it's so unusual that it's not built in the cockpit anymore, or nowadays, okay? So those systems exist. So planes can land without a hydraulic system, based on engines only, engine power, okay? But because it's so rare, like Boeing and all those, like Airbus, they're not building this in their planes. Very useful information, yeah? Okay. Now, we're going to continue. We have had the if-else statement here, yeah? We also have an if-else, if-and statement, okay? So if x is smaller than y, and x was -1 and y was -2, so that's a relational operator, and we know that x is not smaller than y. So automatically we know that MATLAB is not going to execute line 49, because the statement on line 48 is wrong. Then we used to have an else statement, and the else statement meant that if the first statement is wrong, no matter what, always execute the second statement. But an else-if statement is slightly different, because the else-if statement also specifies a relational operator, and this needs to be correct before it actually does line 51. So is y larger or equal to x? In our case, y is -2 and x is -1. So this is not true either, yeah? You guys are looking at me as this is a difficult course, which it is a little bit, but... Okay, so line 48, x smaller than y, if x smaller than y, that's not true. So I would never execute line 49. But y is not larger or equal to x, because y is -2. -2 is not larger or equal to -1. So I will not execute line 51 either. So I will go, or MATLAB will go through this series of steps and not do anything. Because both statements are not true. If on the contrary, I would add else display hello, yeah, now what it will do, it will see that the first statement on line 48 is not true, because x is minus 1 and y is minus 2. So line 41 is not executed. Then line 50, else if, is y larger than or equal to x, is also not true. So line 51 is not executed either. And then with the last else statement, I can just say, okay, you know what? If everything turns out to be not true, then just do something. Yeah? So you can do, this is the way you can use else if. If you don't use else if, then automatically if the first statement is not true, you will go to the second statement after else. If you use an else if, you build in another constraint or operator that needs to be checked. So it is possible that with an if-else-if loop, that you actually don't do anything at all, because both statements turn out to be not true. Okay, and here's another example. And you can play with that at home. Now, switch statements, okay? Again, these are just things that it might be overwhelming now, but if you play with it a little bit, believe it or not, most students, they pass this course. Okay? With a D minus, but still they pass. Okay? Line 71, I declare a variable x. X is 2. And now MATLAB has a built-in function called switch. Okay? And what I do here is I switch based on the sign of x. So I compute the sign of x. And sign is another built-in function that from a number checks whether it's positive, negative, or 0. If it's positive, it returns a 1. If it's negative, it returns a minus 1. And if it's 0, it returns a 0. So the sign of 10 is, the sign of minus 10 is minus 1, and the sign of 0 is 0. So this is just very useful function to figure out, is my number positive or is my number negative, or is it 0? Now, and with the switch statement, you can actually print that to the cockpit, to the pilot, yeah? Imagine that x is the percentage alcohol in his lunch, and he likes to know when he's going to fall asleep. Okay, so there's a switch statement built in the material, in the entire the cockpit software, and the switch based on the sign of x. If the sign of x is minus 1, we write case minus 1. Then display x is negative. If the answer of the sign of x is 0, then the case is 0. Then we display x is exactly 0. If the case is 1, display x is positive. Otherwise, the test failed. And this is impossible because the sign is either negative, positive, or 0. So minus 1, 1, or 0. Okay? But you can have this otherwise statement, the same as this else statement, that if everything fails, just display something, do something, that it's clear that all the other things failed. Now, so this is a switch. So the terrorist list with the name, the person from Amsterdam, might be on that terrorist list and might have his last name, and you could have then a switch statement based on his last name. Yeah? If his last name is Vrugt, yeah, then switch, and then it could say, then check his first name, Jasper. If his first name, if case Jasper, then kill him immediately. Yeah? If, now, and that's how the stuff like this is built in software. Like all the windows that you're using, that's all built in. Now, we can use the same as this switch statement with an if-else statement, of course. Okay? We could do, if the sign of x is minus 1, then x is negative. Else if the sign of x is 0, then x is exactly 0. Else if the sign of x is 1, then x is positive. Else, if none of them were true, the sign test failed. So we can use an if, else, else, and statement for a problem where we use a switch statement. So you can choose yourself which one you like best. Yeah? People are looking at the screen as if they've never seen Windows. But so one thing, with an if, else, and statement, only one of those statements can be true, yeah? So typically, if the first one is true, like line 84 for instance, then automatically after it executed line 85, because line 84 was right, it went to line 85, then automatically it goes to the end. In most cases. You can make some exceptions. Okay? Now, switch has an advantage because why would you want to work with switch? Because it can also work with strings. For instance, here I have an example. Imagine you're a chemical engineer. You're doing an experiment in the lab and you want to quickly figure out from a database what are the properties of a certain mixture that you have. And imagine that mixture is oil. Yeah, and you like to know like the surface density, you like to know the density of it, the liquid itself, etc. You like to know number of things of this substance. So there's a database, and you put in, you have a program, and you define, okay, my material is oil, and that database, what that does is that it switches, it goes through all these materials, and what we see that in case that my material is oil, that density is 3. Okay? So if I would, for instance, put in here, I could put in like some nice medication doctors give, or something else like Coke. Yeah? Now that's not in my database, so what happens is that it will do line 105, material unknown. That's rather strange, but that means you didn't have it entered in your database. So the switch statements work both with numerical values as with strings. Okay, so that's an advantage. Now we move to for loop. So this is a lot of information, but we're going to repeat this, okay, over and over again. And please, again, work with it at home. So remember, we can create a vector with the option linspace. Yeah? We can create a vector of values here between 0 and 10, 11 values. Now this statement, if I execute this statement, I have these values. And what you see, if I do the size of x, is that I have one column with 1 row with 11 columns. Okay? Between 0 and 10, because that's what I asked for. Now the same thing I could do is, and you have seen this also, if I execute this statement. X is between 0 up to 10, and it's nicer to specify for beginners the step size. So I move from 0 to 10 with step size 1. You're going to get the same result as that linspace thing. Okay? But if the step size is 1 in MATLAB, you don't have to specify. Okay, so if you don't specify a step size, MATLAB assumes that the step size is 1. Now, obviously, I can also specify a step size perhaps of 1.25. And you're going to get these numbers. Okay, because I still had my format on long. Okay, so this is how you see how I move from 0 to 10 with a step size of 1.25. But we'll go back to 1 here, so we have this, nice round numbers. And now let's illustrate the for loop. So A for loop we use if we want to execute the same statement over and over again. Okay? So imagine you have a database with serial killers. Yeah? And you have all the people of America in that database. Yeah? And we know from each individual whether that person is a serial killer or not. If he is a serial killer, he has a value of 1. And now I write a for loop that loops over all the different names to check whether that person is a serial killer or not. So if I see a value of 0 associated with that person's name, then he's not a serial killer. Whether if I see a value of 1, then he is a serial killer. So we know about this case in Long Island, yeah? The Long Island serial killer. No one knows about that case? Oh, okay. Please Google, that's a person that has killed people since like 1994 or so. Like 14, 15, 16 people were killed. They were found on a remote beach, body parts. Some are still floating in the Atlantic Ocean, I don't know. But check that out. It's a very interesting case because it's a case that might have been going on for 20 years already. Okay, so they have a composite of the person. It's not me, by the way, so don't call, but I don't have desires in that direction. So, like if we go to line 122, a for loop. Now, a for loop has a counter. In this case, a for loop starts with for and it ends with and. The same as our if-else end statement. In that case, we start with if and we always end with end. So the for loop is the same. We always end with an end statement. And you should read this at home, yeah, because I explain everything here in detail in the text with the percentage symbols. You know it's text. So for I, the way we read this is for I is 1 to 11, which means that the first time I go in this loop, I start at line 122, and the first time I execute that line, I is 1. Then I go to line 123, and then it says xi, and I is 1, so x1 is I minus 1, is 1 minus 1, so x1 is 0. So the point here is that I can quickly create a vector x with this statement. Yeah, we've seen that here. We can create, it's very convenient with one line. This statement does the same thing. Okay? But now it's a for loop. So the first time I go in this loop, I is 1, and then it says x1 is 1 minus 1. So x1 is 0. Then I see end, and I know that I is 1. I know from the top that I should go all the way to 11. Okay? And those for loops, again, I don't specify a step size because I say from 1:11. That means automatically I use a step size of 1. So the first time I go in this loop thing, I is 1. Then I go back because I know that I'm not at 11 yet. Then the second time I execute this statement, I becomes 2. And then it says x2 is 2 minus 1, which becomes 1. Then the third time I go in here, it says y becomes 3. It says x3 is 3 minus 1 is 2. So if I actually plot this to the screen, what you see happen is, I'll clear x here, yeah? I just let this go, and this is what you see. You see that the first time it is a 0. So the first element of x is 0, and then the second element of x becomes 1, the third element of x becomes 2, the fourth element becomes 3, the fifth element becomes 4, and this is just printing to the screen. You see every time that you add one element. So this is a for loop, that you execute the same statement over and over again and you have a counter where I is called the counter, you can call the counter anything. Okay? So what you indicate is 4 and then the name of the counter and then is the start of the counter 1 all the way to 11. And you could use 5 to 25 or 795 up to like 1200. Okay, so everything is explained in this text, okay? So please read that at home. Okay, so this statement over here is I start now here at 1 and I loop to 11. Okay, I could also start at 0 and loop to 10, but then what I need to do is I specify I plus 1. Because when I is 0, then I have x0 plus 1, which becomes x1 is 0. When I then becomes 1, I get x2 is 1. So this statement on line 132 all the way to line 134 is the same as line 122 to line 124. And we know that MATLAB, unlike other languages, the first element of a vector is the first element, okay, x1. Some languages start with x0 or y0. They can have a zeroth element. Okay? MATLAB, the first element of a vector, of a matrix, is always the first element, not the zeroth element. And that's why I have over here I plus 1. Because if I do xi, I leave the 1 out, then I have x, the zeroth element of x, and MATLAB will crash because MATLAB will always start the vector, will always go from element 1 to the last element and not from element 0 to the last element. Now why is this useful? Now we have our x values now, yeah? So imagine you want to compute the sum of these values. Okay? Now MATLAB has a very simple built-in function where you just do the sum of x. Okay? So it's 55. Again, sum is the built-in function, where x is the vector of which you want to compute the sum. So it basically computes, it just sums up all the numbers of the vector. And if you do that well, you'll get to 55. But we can use a for loop for this, where we declare a variable sum x that starts at 0. Okay, and then I loop from 1 to the number of elements of x, okay, the size of x, 2, and we know that x is a horizontal vector, so the size of x was 1 by 11, and if I do size of x, 2, I'm going to get the 11. So that first statement, this statement says I is 1 to 11. And why would you do it this way? Because you make it generic. If I fix 11 in this statement, which I did on top, then I am stuck to vectors with 11 elements. And maybe at one point I have a vector x that has 55 elements or 89. So I want to have it as generic as possible. So what I do here is I say the sum of x is the sum of x plus my current x value. Now the first time I go in this loop, I is 1, so I add the first element of x. The second time I go here, this I is 2. I add the second element of x. So you sum up the different elements, and that's why I initially say that my sum of x is 0. Because if I do not declare my initial sum x value, MATLAB will give a crash because it will say I do not know. I can show you, we'll leave this out. I don't know if it's still... You see, it says undefined function or variable sum x. It doesn't know because we use a statement here. Sum x is sum x plus x1, the first round. But it doesn't know what this sum x is. Never heard of it. So that's why we initially say that sum x value is 0. And now we run it again. And now we have 55. Yeah? And we can also do this for those that like to print. This is how this works, yeah? We start the first time we go in this loop, I is 1. And the sum x is 0. Then the second time, I is 2. Sum x becomes 1. The third time, sum x becomes 3 because x3 is 2, yeah? Now, then we go from, we add 3, then we add, now, etc. You keep adding and you see the y counter, the I counter going up from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11 and then we have the answer 55. So this is how for loops work. So you're executing the same statement over and over again. Okay? Now, with for loops you don't only have to have counters that count up from 1, 2, 3, 4, 5, 6. You can also have them count down. And that's what you see on line 172, where we have a counter called k that starts at 10 and it's counting down with step -1 back to 1. Okay? And my element here, y, the first time I feel that the first time I go in this loop, I start here, I have y10 is the sinus of 10. Then I go back and then y9 is the sinus of 9. Then the third time is y8 is the sinus of 8. And you go all the way back to y1 is the sinus of 1. And then end, because as soon as k has become 1, the loop knows we're ending. Because you initially told me that the loop is between 10 and 1. And once I achieved my minimum or maximal counter value, I'm going out of this for statement. Okay? Now, we will continue next time with the while loops, but there's a few remarks that I like to make. We still have a few minutes, okay? So please, there are questions. I got an email from someone that said, Jasper, I downloaded all the software, I'm trying to run the codes, but I cannot run it because somehow MATLAB does not recognize the function that I wrote. So what's really important, that on top, yeah, you see, if you look on top, you see current directory, C, /UCI, /teaching, /CE20, /2013, /coach, / all that stuff. So that's the current directory that I'm working in. Lecture 5, because we're Wednesday, second week. Yeah? First week we have 3 lectures and then, now, etc. So point is that I can look in that directory that's up top, which files are there. These are the files that are there. Okay? And that's why I can only execute these files. Okay? So MATLAB will only be able to execute the scripts that you write in the directory that MATLAB or Octave is in. And the way to figure out which directory you are is, in Octave for instance, PWD, it will tell you which directory you are in. And if you want to change the directory to the directory of your scripts, you can just use this command of cdc / and you just go to a different directory. You just type in the directory you want to go to, in which you have your scripts. So in other words, it's really important that you work in the same directory as that you have your scripts in. Otherwise, MATLAB is going to say, I don't know what script you're talking about because I don't see it in the directory. MATLAB is, you could make certain files global files, that MATLAB will always recognize them. Those are the built-in functions. But the functions that you write, you need to work in the same directory. That's why each time, each lecture, I switch directory. For instance, for Friday, you see here, now I'm in this directory. I can do, then I go back, and now you see I have to go to lecture 6. And then here you see I have my lecture 6 files, and then I can open lecture 6 script. And here, this is lecture 6. Okay. So, last thing, if you have questions, I will start with questions at the beginning of the session, okay, for a few minutes. But so far there are not really a lot of questions. But please feel free to ask questions. And for those that did the quiz today, about the same scores as on Monday, and there was a few people with a perfect score.